Welcome to PreMath. In this video, we have got this right triangle ABC along with this perpendicular CD, as you can see in this diagram, such that this side length AB is represented by C is 8 units, whereas this side length AC is being represented by lowercase b is 5 units. And moreover, this side length BC is being represented by lowercase a. This perpendicular CD is being represented by lowercase h. This blue segment BD is being represented by lowercase p. And finally, this red segment AD is being represented by lowercase q. And now our task is to calculate the missing side A, missing side H, missing side P, and finally missing side Q. In other words, we are going to find the values of A, H, P, and Q. Please don't forget to give a thumbs up and subscribe. And please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. And here's our very first step. Let's assume that alpha and beta are our two complementary angles. In other words, the sum of these two angles, alpha plus beta, must be equal to 90 degrees. So therefore, let's assume that this angle is our angle alpha. Since this is our 90-degree angle, so therefore this angle has got to be our angle beta. And now let's focus on this triangle BCD. This angle is beta, this angle is 90 degrees, so therefore this angle has got to be our angle alpha. And we know this angle is 90 degrees, so therefore this angle has got to be our angle beta. So therefore we can see that these two right triangles, triangle BCD and triangle ACD, are a similar triangle according to angle similarity theorem. So therefore we are going to have a proportion. So therefore we are going to have a ratio of CD and BD. Here's our CD and here's our BD is going to be equal to the ratio of AD and CD. Once again, this is our AD and this is our CD. And now we can see our CD length is being represented by lowercase h. Likewise, this CD is lowercase h as well. This BD length is represented by lowercase p, and this AD length is represented by lowercase q. Let me go ahead and cross multiply. So therefore we are going to have h square equals to P times Q. Let me label this our equation number 1. And please keep in mind that this relationship h square equals to P times Q is called the Euclid's theorem. And here's our next step. Let's focus on this right triangle ACD, whose side lengths are lowercase h, lowercase b, and lowercase q. And now we are going to apply the Pythagorean theorem on this triangle. And here's our Pythagorean theorem: a square plus b square equal to c square. And in our case, our hypotenuse is lowercase b. So let's go ahead and fill in the blanks in this Pythagorean formula. So we got h square plus q square equal to b square. And now let's focus on equation 1. We know our h square value is p times q. So therefore I'm going to replace this h square by p times q over here. As you can see in this next step, I have replaced this h square by p times q. And here we can see q is in common between these two terms. So therefore I can write q times p plus q equals to b square. And now let's make an observation. We can see that this side length AB is being represented by this lowercase c. So therefore this lowercase c is going to be equal to the sum of this p and q. In other words, I can write p plus q equal to c. So therefore I can replace this p plus q by lowercase c over here. So therefore we can write q times c equal to b square. And if we put it other way around, we can write b square equal to q times c. Let me label this our equation number 2. And now this equation is going to be very handy. And here we can see our this c value is 8. So I'm going to replace c by 8, and we know our b value is 5. So I'm going to replace this b by 5 over here. So therefore after substitution, b value is 5 whole square equals to q times 8. Let me divide both sides by 8 to isolate q. So therefore our q value turns out to be 25 divided by 8. So therefore our this q value turns out to be 25 divided by 8. And now let's make an observation. We can see that this whole length is being represented by lowercase c. So therefore this BD length, which is p, could be written as c minus q. And now we know our c value is 8 and our q value is 25 divided by 8. As you can see in this next step, I have replaced c by 8 and q by its value 25 divided by 8. And if we simplify everything, our p value is going to be equal to 39 divided by 8. So therefore our p value turns out to be 39 divided by 8. And here's the next step. Let's focus on this equation 1. And here I have copied down our equation 1, h square equals to p times q. And now we know our p value is 39 divided by 8 and our q value is 25 divided by 8. So therefore after substitution, h square equals to 39 divided by 8 times 25 divided by 8. Let me undo this square by taking a square root on both sides. So therefore on the left hand side we got lowercase h value is going to be equal to 5 times the square root of 39 divided by 8. So thus our lowercase h value turns out to be 5 times square root of 39 divided by 8, as you can see over here. And now our task is to find the value of this lowercase a. So therefore let's focus on this big right triangle ABC. And now we are going to apply the Pythagorean theorem on this triangle. And here's our Pythagorean theorem once again: a square plus b square equal to c square. And in our case, our this side length is a, this side length is 5, and this hypotenuse is 8 units. So let's go ahead and fill in the blanks in this Pythagorean formula. A square plus b in our case is 5 whole square equal to 8 square. Let's simplify. That is going to give us a square plus 25 equal to 64. Let me subtract 25 from both sides. This is gone. So therefore a square going to be equal to 39. Let me undo this square by taking a square root on both sides. So therefore our lowercase a value is going to be positive square root of 39. So thus our a value turns out to be square root of 39. So thus here are the values of our missing side lengths: a, lowercase h, p and q. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.